when you take into account only the one-page document given to you, and when you take into account only the meeting you had with the informant, certainly you will have an inadequate description of the problem context. Also happens with the problem analysis, when no key tools are provided to understand what is going on and to actually bring new insights from literature. The question is how author engineers and scientists have dealt with the same problem. What did they do? What is the nature of the system? Which brings me to the second point. No system description, no scope, no drawing with inputs, outputs, subsystems, and interrelations. Then we don't really understand what's the complexity of the problem you are dealing with. Certainly, before setting your problem statement, you should define your system. And it doesn't matter if it's a fundamental research question or a practical problem for an industry. Sometimes you can actually find the system already published in a paper or book. You can bring it to your own report, but you must, of course, make use of a good referencing system. You can adapt such a system, or certainly you can draw a system based on your own assumptions and based on what you have read so far in the scientific. Once we have a good grasping of the system, once you have made use of adequate tools, probably the whitewad model, for instance, probably the stakeholder analysis actually provide new insights, or an Ishikawa diagram when you are brainstorming potential issues, then we are ready to write down the problem statement. It's the problem context and the problem analysis, the one that should inspire that problem statement, which should be written in 1 or 2 sentences, and also should be explained. When the problem statement is ready, when you have a good grasp of your system, when you have made use of good tools for analysis, and the context is rich, then it's time to elaborate your research objective. And for that, you can make use of the SMART tool or the Verdot tool. Also, you can bring new papers here to justify your assumptions. Then those actually become educated assumptions. Certainly, the objective needs to be explained, which will bring coherence to your storyline. Another point for improvement is the presentation of your core questions. Whether this core question has the steering function, meaning that you are addressing already potential methods and tools, or whether it has the efficiency function, meaning that the question has elements of the objective. Sometimes you even propose 2 or 3 core questions, when the case aims most of the time only for one, but of course that depends on you. Let's assume that you have now a very good core question, but most importantly that you have the research objective, which is now SMART. Let's think about the research sub-questions. What are those stepping stones that you want to reach with each of the sub-questions? They should be actually clearly explained. And if I answer those sub-questions, it means that I am answering the core question, which means that I am reaching my goal, the goal of the project. The key word is the stepping stone, connected to a sub-question, which actually should be also connected to your scientific tools and methods. Enriched with literature could be that the papers that you have used during your problem context and problem analysis, or the elaboration of your research objective, are also representative to justify the methods and tools. Think about those stepping stones. One important remark here, and it's something that we see again and again, is the so-called ticking boxes. Qualitative versus quantitative. Of course, we are dealing with engineering problems. Most of the time, if not all the time, is quantitative because we avoid, in principle, verbosity. Are we going to run surveys? Yeah, most probably, but that doesn't really say so much. What we would like to see is representative methods and tools. Are we going to deal with an experimental setup? It's a pilot. It's a test bed. It's a numerical simulation. What is precisely the method or what is precisely the software or the tool that we will need to answer each of the sub-questions? The book was meant to shape our mindset, but it doesn't mean that we need to tick the boxes with respect to materials or strategies or even the planning. The inspiration for the case should now come not directly from the book, but should come from the scientific literature that you should find via Google Scholar or Mendeley or the services of the library. And last but precisely not least, it's a reflection, it's a section you should include. What are you going to deliver at the end? What's the nature of your artifact? How are you going to convince your problem owner and the main stakeholders that your artifact actually will solve the problem, will reach the objective? What is the scientific validation process? And this validation process can be also inspired by the methods and tools that you will use to answer the sub-questions. The deliverable, please don't forget about that section. And this is bonus material. 3 of my favorite places to find scientific literature, from Google Scholar to Mendeley and Google Books. Google Scholar is very good for cross-checking references, and Mendeley actually is very good to see and to sort by number of citations and by amounts of time that the article was read, or just popularity. Both complement each other. And if I want to dig further into a book, sometimes specific pages are open and you can easily find them via Google Books. Success with the elaboration of the synthesis case.